VPC endpoints. Till now we have seen interaction between EC2 instances and internet. AWS has a lot of other services which will be discussed in due time. Sometimes your EC2 instances need to talk to these services. For example, application in EC2 instance wants to put files in S3 storage. S3 is a global service that can be accessed over internet using encrypted connection. Typically what happens is that before getting uploaded to S3, the file travels internet. This can be avoided using VPC endpoints. Endpoints work with Kinesis Streams, DynamoDB and S3. We'll see demo of VPC endpoint after completing these topics. Let's look at the concepts now. There are two types of endpoints, gateway endpoint and interface endpoint. These endpoints enable applications in VPC to connect to supported services without using internet gateway or NAT or VPN connection. Instances in VPC do not need public IP addresses to communicate to these services. That means EC2 in private subnet can very well talk to these services. These traffic never leave Amazon's network. Let's see how gateway endpoints work. We have a VPC, AZ and two subnets, one private and one public. We have internet gateway which can connect to internet. This is known terrain for us. We have S3 and DynamoDB here. There is one EC2 instance in the public subnet. If this instance wants to send data to S3 or DynamoDB, then it will go via the internet gateway, then internet, and finally reaching S3 or DynamoDB. If you have an instance in private subnet, we'll need a NAT gateway or NAT instance in the public subnet. Traffic will go to NAT gateway, then to internet gateway, then internet, and finally to S3 or DynamoDB. But all these are in AWS itself or in Amazon network except for internet. Then leaving Amazon network for internet and then coming back again does not make much sense. Can you achieve the same goal with lesser components, lesser overhead along with lower price? This is where endpoint plays a role. Remove all these. You do not need internet gateway, NAT gateway or internet. Put an endpoint in the VPC. Then instances from both public and private subnets can talk to these services via VPC endpoint. If you see, traffic never left AWS network at all. Make sure to take care of the routing table, which is an important piece to achieve all these. This is how our route table would look like. Traffic destined to S3 should be targeted to VPC endpoint. We'll see practicals on this after we cover S3 and DynamoDB sessions. Second type is interface endpoints. This works using something called private link. It works using network interface. Things are more or less similar. We have VPC, AZ, subnets and EC2 instances in those subnets. We have another AWS service, Kinesis, and we want to connect to this without leaving Amazon's network. An interface endpoint can be created in one of the subnets, and EC2 instances can connect to Kinesis via this interface endpoint. This is the route table. As we are creating network interface in the subnet, no routes need to be changed. We'll use the existing local route. How to create VPN connection in a VPC? Before going into VPN in VPC, let me give you an introduction on how VPN works. VPN on virtual private network, we'll try to understand it using home network. I'm giving this session from my home using my computer behind my router. And you are listening to it from your computer or phone behind your router. When I talk, my voice signals get transformed into ones and zeros and get uploaded to my router. Router sends the signals to internet. Signals travel the entire world, eventually landing into your router and then to your machine. What if I was sending some sensitive information? That would also travel via internet. As internet is accessible to everyone, some bad guy can peek in and download or get all this information and use it against us. We should not let this happen, right? VPN helps here. If you have VPN on these machines, then it creates a tunnel between my machine and yours, and all data that is transferred will be encrypted. Even though bad person downloads all data, it will not make any sense to him as all data will be encrypted. All these encrypted data can only be read by my machine and yours. The same concept can be implemented in enterprise data centers as well, or between data center and AWS cloud using VPC VPN. When you use data centers and AWS, then it is called site-to-site VPN tunnel. VPN tunnels are implemented using something called IPsec. You do not need to know what IPsec is. This concept should suffice. VPN connection between corporate data center and AWS is implemented like this. We have our usual components in AWS: VPC, AZ, subnet, EC2 instances. This is what the corporate data center is. Servers run in this data center. Three components are needed to create IPsec VPN tunnel between VPC and corporate data center. First is the virtual private gateway. This is the VPN concentrator on AWS side of the VPN connection. Virtual private gateway is created and attached to the VPC just as it is done with internet gateway. Second component is the customer gateway, which is a physical device on corporate data center. It can be a Cisco ASA device or Juniper device. Finally, the VPN connection, which creates a VPN tunnel between these two. Always two tunnels are created, one remains active, because if one goes down, then communication is kept alive using the other tunnel. This is done for high availability. Route tables have to be modified accordingly. Suppose these are the network addresses of VPC and corporate data center. If you want instances in your VPC to be able to connect to servers in corporate data center, then you can modify your route table like this. This means any traffic destined for corporate data center should be targeted to virtual private gateway. Same setup has to be done in the corporate networks route table also. This is called route propagation. Let me show you how you create these components. In this demo, I'll create a VPN connection between our existing VPC, which is 3-tier architecture, and a corporate data center. I cannot show you the entire demo because I do not have any data centers of my own, but I'll show you how to create the components and attach them with the VPC. Go to the VPC console, go to VPN connections and click on virtual private gateway, which is our first component. We'll be creating all three components: customer gateway, virtual private gateway, and VPN connections. First should be the virtual private gateway. Give it a proper name and create the virtual private gateway. Once created, attach it to the VPC. In our case, it will be 3-tier architecture VPC. It will take some time for the virtual private gateway to be attached to the VPC. Once attached, the state would change from attaching to attached. The next component would be customer gateway. Click on create customer gateway. Give it a proper name, and IP address should be the public IP address of the device which is there in corporate data center. It can be Cisco, it can be Juniper, it can be anything, but it has to be a physical device. And as I said, the IP address should be the public IP address of the physical device so that it is reachable over internet. Click on create. Two components have been created. Now the customer gateway is available, whose IP address is this one, 54.27.14.8. It's a hypothetical IP address. I do not have any customer gateway of my own, so I've just provided this IP address for example's sake. There's something called BGP ASN. Let's not go ahead and discuss BGP ASN right now. We'll be discussing it later on. These two components are done: the virtual private gateway on our VPC side and customer gateway on the corporate data center side. Now the VPN connection has to be created. Click on create VPN connection. Provide all the required details here. First the name tag, then the virtual private gateway. In this case, we'll attach the virtual private gateway which we just created. Similar is the case with customer gateway. We'll provide the customer gateway which we just created. And in routing options, I'll mention static. And in static IP prefixes, it should contain the private network address behind your device. This is the private network I'm talking about. So you have servers here, and these servers should belong to a network address. In static IP prefixes, you'll have to mention the network address of that LAN. Let's say it's 10.20.0.0/16. Again, it's a hypothetical one. I'm just showing you an example. There's no actual network address as this one, but yes, if you want to create a VPN connection, you'll have to provide the CIDR block of the network address, which is behind your device or behind the customer gateway's device. The VPN connection has been created. The state is pending. Once the state becomes available, you have to download configuration. This configuration is for the device which is there in your corporate data center, and that device can be from any company. Click on download configuration, and in vendor, select the vendor which you want to choose. So in this case, it might be any one of these devices in your corporate data center. It can be a Cisco device, it can be a Juniper device, it can be a Citrix device, so on and so forth. So let's say I have a Cisco device, so I'll choose Cisco Systems Inc. And then we'll have to mention the platform. We'll have to check with your network administrator what platform they are using. It can be ASA 5500 or CSR VMI or ISR series router. Based on the platform, we'll select the corresponding one. Once you get the information from your network administrator, you'll have to get the information about the software also. Typically, as of now, it can be 8.2 plus or ASA version 9. Let's say it's with ASA version 9. Click on that particular software and then select download. Once you download, AWS gives you this file. Now this file is very important. It has to be used in your corporate data center. So give it this file to your network administrator and log into the devices admin page and use all the commands as it is mentioned. Remember, do not change anything. Use exactly as it is mentioned. Don't change any of the parameters in the commands. Once the device is configured using commands mentioned here, you can see two VPN tunnels up and running. Click on VPN and click on tunnel details. Both these VPN tunnels would be up and running. In our case, both are down because we have not done any setup. That's all, the VPN connection is up. The final piece of this puzzle is route propagation. Our VPC 3-tier architecture has three subnets: DB, app and web. You have to choose which subnet you want to have connection with your corporate data center. Let's say we want the DB subnet to have VPN connection with corporate data center. Go to DB subnet, select its route, go to route table and then change the route. Click on route propagation, edit and enable the route propagation. After enabling route propagation, the path for this subnet would be modified with an additional route. It would be something like this. This route would be added. Let's say the private network address behind the customer gateway device is 11.22.0.0/16. So all traffic destined for this corporate data center's network address will be targeted to the virtual private gateway. Of course, you have to modify security groups and network ACLs for this to work. Once those are done, the entire VPN configuration has been set up. Now, this DB subnet in your VPC can talk to the network in your corporate data center. Once you are done testing, please go ahead and delete all the setup so that you don't get. First, you have to delete the VPN connection. Then go to virtual private gateway and detach it from the VPC first. After detachment, delete the virtual private gateway. And finally, delete the customer gateway. Let's see a few VPN configurations. You can connect your single VPC with multiple data centers using multiple VPN connections. Redundancy can be used to failover capabilities. You can create multiple IPsec VPN tunnels between your VPC and corporate data center to provide redundancy. Let's talk about another technical concept which is called VPN CloudHub. If you have multiple VPN connections to multiple data centers in different locations like this, secure communication between sites can be provided using AWS CloudHub, which enables these remote sites to communicate to each other with VPN connection. That means all traffic would be encrypted. VPC Flow Logs. It is a feature that enables us to capture information about the network traffic going to and from network interfaces in your VPC. Flow log data is stored using Amazon CloudWatch logs. After you have created a flow log, you can view and retrieve its data in Amazon CloudWatch logs. This is your VPC and you have elastic network interfaces attached to EC2 instances. All your network traffic come to these network interfaces, and these traffic can be from anywhere. For example, it can be from internet, it can be from another VPC, it can be from other EC2 instances in same VPC or different, from load balancers, etc. This data is logged in VPC Flow Logs. Then these are uploaded in CloudWatch logs for later view and analysis. Flow logs can be created at network interface or subnet or VPC level. If flow log is created for a subnet or VPC, each network interface in the VPC or subnet is monitored. Let's enable flow log and see what data is captured there.